carbon filter works in partnership with an inline extraction fan. The fan is needed to move air over a carbon bed. The carbon absorbs organic molecules, such as odors, and the resulting air is purified and odor-free. That's the very basic theory anyway. Carbon filters in a kitchen or a bathroom have an easy life compared to the carbon filters in your grow room. Why? Well, because ventilated indoor grow rooms need to exchange air much faster. Carbon filters invariably form an integral part of this air exchange system. You need a very high-performance carbon causing minimal air resistance to your extraction fans. Put another way, if your carbon filter bottlenecks your extraction system with too much air resistance, you'll likely end up with a hot, stale grow room full of unhappy plants. Some growers spread the load by using additional carbon filters as air scrubbers within their grow rooms. The purified air is recirculated, not extracted, removing not only odors but also molds, spores, and pathogens. Whereas the same air may pass through a scrubber several times, a carbon filter is used as part of a grow room's extraction system, typically has just one shot at removing any remaining odors and particulates present before it meets the outside world. Okay, what size carbon filter do you need for your grow room? Step 1. Work out the volume of air used for growing. Example, if your grow room is 10 feet by 12 feet and your ceiling is 8.5 feet in length, the volume is 10 times 12 times 8.5 or 1,020 cubic feet. That's about 29 cubic meters for any sensible metric people out there. Remember, I'm talking about the volume of air used for actually growing here. If you had a room this size but were only using half of it to grow your plants in, you could divide this number in two. Similarly, if you're growing in a tent, it's the air volume of the grow tent itself that you need to factor into your calculations. Step 2. Calculate the size of the extraction fan required. Go big and use a fan speed controller to give yourself some wiggle room. An indoor garden full of mature, heavy fruiting annuals is much thirstier for CO2 and transpires loads more moisture into the air. This is when you actually need to exchange your garden's air once every 60 seconds. Young plants don't need so much air exchange, but we need to spec our ventilation so we're good for the entire life cycle, obviously. So, in our example, we need to exchange 1,020 cubic feet of air each minute. You'd be looking at something like this 10-inch hyperfan that can shift 1,065 CFMs or cubic feet per minute. Also, this formula sucks if you have really high ceilings, 10 feet or more, so just use 9 as your ceiling height for the purposes of calculation. Okay, what about the carbon filter? Well, the final step is easy. Carbon filters are rated in CFMs or CMHs too, so finding the right match is fairly straightforward. Make sure you choose a carbon filter with at least the same rating, but for optimal performance, add 20%. A 10-inch fresh filter, 39 inches long, is rated at 1,400 CFMs, so it's the perfect companion here. But how do these things actually work? Well, it's all thanks to something called activated carbon. Using either chemicals or pressurized steam, millions of tiny microscopic pores are opened up in the carbon as part of their pre-manufacturing process, leaving it charged with positive ions. The result is carbon with a very large internal surface that acts as a magnet for odors. Cheaper carbon filters sometimes use Chinese and Mongolian granular carbons, sometimes even claiming that they're Australian mesopore carbon. Unscrupulous, to say the least. Avoid these knockoffs like an angry escaped rhinoceros at a zoo, mate. Now, reversible carbon filters are an option if you're short on space in your garden. Most growers suck air through their carbon filters, which requires the carbon filter to be in their grow room, usually suspended from the ceiling or the grow tent roof. This is so that it removes and purifies the hottest and therefore smelliest air from your garden. However, if your carbon filter is reversible like this one, it's worth noting that you can also blow air through it instead. Just be sure to place the dust filter on the inside, like this, rather than on the outside. This arrangement can be handy if you're extracting into another intermediate room or if you're growing in a confined space where there's no room to hang a filter. Next, a word on humidity. If your grow room's relative humidity is over 85%, then your carbon filter will stop working. Plug in a dehumidifier as your plants won't be happy either. Once your grow room's air is drier, your carbon filter will dry out too and start working again. Note that a carbon filter doesn't have to be the start or the end of your ventilation system either. You can buy inline filters too. Now, some growers combine an inline carbon filter with an ozone generator, treating the air before it reaches the inline filter. The ozone breaks down odors, making them easier for the carbon filter to deal with, extending its working life. You should replace your carbon filter every year or two if you're using them continually, 24/7 as most growers do. They can last up to 4 years in less demanding situations. So, make a note to put your pre-filter dust socks in the washing machine every 6 months or so to remove the large dust particles and maintain maximum airflow. Make sure they're fully dry before returning them to service. To summarize, it really doesn't matter what shape your carbon filter is as long as its stated CFMs are up to your grow room's maximum ventilation requirements as explained earlier. One final piece of advice. Always keep a spare. Not only can this be quickly deployed if you notice an odor problem on, say, Labor Day, but a spare can be really handy at harvest time when your air filtration needs sometimes hit their peak. Okay, I think I've covered everything I wanted to. Questions and comments below as always. Thanks for watching, and here's to waving goodbye to odor problems forever.